Take a look at the next problem, students. When a piece of a metal is illuminated by a monochromatic light of wavelength lambda, then stopping potential is 3 Vs. When the lambda is replaced by 2 lambda, then the stopping potential becomes Vs. The value of threshold wavelength is options A 4 lambda, B 8 lambda, C 4 by 3 lambda and D 6 lambda. Students, we know that when the incident wavelength is increased, incident energy decreases, which in turn decreases the maximum kinetic energy of the emitted photoelectrons, or in other words, the stopping potential decreases. In the given problem, there are two cases. In the first case, the incident wavelength was lambda, for which stopping potential is 3 Vs. When lambda is doubled, in the second case, the incident wavelength is 2 lambda, then obviously stopping potential must decrease. It is reduced to just Vs. And you are supposed to find out the threshold wavelength. Obviously, this problem is based on Einstein's photoelectric equation, but which form of the equation should be used to solve this problem? You know, kinetic energy, maximum kinetic energy is E minus phi, E minus work function. So, that maximum kinetic energy should be written in terms of stopping potential, and phi should be written in terms of threshold wavelength. And the very famous formula which connects the stopping potential to threshold wavelength is, obviously this problem should be written in terms of wavelengths only. So, forget frequency. So, how do I write my equation? It is E into V. Here V refers to stopping potential is equal to, this is my maximum kinetic energy. What should I write here? Incident energy minus work function. So, hc by lambda minus hc by lambda naught. I will directly take that hc common. This is 1 by lambda minus 1 by lambda naught. Now, there are two cases explained in the problem. Let me substitute directly. In the first case, the incident wavelength is lambda, for which the stopping potential is 3 Vs. How do I write the equation? 3 EVs is equal to hc into 1 over lambda minus 1 over lambda naught. This is the first case. In the second case, what do we change is replace lambda by 2 lambda, which results in the stopping potential reduces to Vs. So, the corresponding expression will be EVs is equal to hc into 1 over 2 lambda. However, threshold wavelength lambda naught remains the same. Equation number 2. What is asked? To get lambda naught in terms of lambda, take the ratio. When I take the ratio of say 1 by 2 gives, in LHS I am left with 3, in RHS hc gets cancelled. So, I am left with this part divided by this part, take LCM, lambda into lambda naught. This is lambda naught minus lambda, this is numerator part. In denominator I have 2 lambda into lambda naught, and in numerator I have lambda naught minus 2 lambda. So, lambda naught gets cancelled. Look at this carefully, 2 goes to numerator. So, 2 into lambda naught minus lambda divided by lambda naught minus 2 lambda is 3. Cross multiply to get lambda in terms of lambda naught. 2 lambda naught minus 2 lambda is equal to 3 lambda naught minus 6 lambda. So, minus 6 lambda this side will give you 6 minus 2, 4 lambda is equal to lambda naught. So, what are we supposed to find out is, what is lambda naught? Is there an option? Yes, look at A. Lambda naught is 4 lambda. Option A is the right answer. Students, take one more problem. The threshold frequency for a metallic surface corresponds to an energy of 6.2 electron volt, and the stopping potential for a radiation incident on this is 5 volt. The incident radiation lies in options A visible region, B X-ray region, C IR region, and D ultraviolet region. Students, this is the most expected kind of problem. I mean to say that most repeated questions in competitive exams are of this kind, in which out of these three parameters which are standard in the photoelectric equation given by Einstein, they will give you any two datas. This problem is also of the same kind. Out of incident energy, work function and kinetic energy, here stopping potential and work function are mentioned. You are supposed to find out the incident energy, using which find out incident wavelength, and finally decide to which region of the electromagnetic spectrum the incident wavelength belongs. So straight away let me take up Einstein's equation, which is incident energy is equal to work function plus maximum kinetic energy. Maximum kinetic energy can be replaced by stopping potential expressed in electron volt. So I want incident energy. Phi is directly work function can be written as 6.2 in electron volt, and maximum kinetic energy is given in terms of stopping potential. I hope all the students are very familiar with the relation between stopping potential and maximum kinetic energy. If stopping potential is 5 volt, then maximum kinetic energy is 5 electron volt, as simple as that. So here it is, stopping potential is 5 volt, therefore maximum kinetic energy will be 5 electron volt. Straight away I got incident energy which is 11.2 in electron volt. But do we directly know to which region of electromagnetic spectrum does this belong? No. To decide that, you need to find its wavelength. So for which I'll equate this to hc by lambda. This is incident energy expressed in terms of wavelength. So using this I'll get my wavelength value. So wavelength is equal to hc divided by 11.2. Now the task is to substitute for hc. As I've already mentioned many times, hc should be expressed in electron volt and nanometer. Let me get the wavelength in nanometer. So what is that value of hc, which is in electron volt nanometer? I hope you remember this value, 1240. This is in electron volt nanometer divided by 11.2, and the answer will be in nanometer. So approximately this is 1200 by 11, slightly greater than 100. So I get slightly greater than 100, let me say somewhere around 110 nanometer. So can you tell me to which region of electromagnetic spectrum does this belong? Certainly not visible, because visible starts from 400, this is less than 400, but not too much less as it goes to X-ray. So this lies between X-ray and visible, of course, ultraviolet. This will be in ultraviolet region, that is UV region is the correct answer. Dear students, now let us take one more beautiful problem. This is already asked in one of the previous IIT JEE paper. I have slightly modified the question. The graph of stopping potential versus wave number is as shown below. If phi is the work function, then pick the wrong statement. Options: A, phi 1 is to phi 2 is to phi 3 is equal to 1 is to 2 is to 4. Option B, tan theta is equal to hc by E. Option C, ultraviolet light can produce photoelectric effect in all three metals. And option D, visible light can produce photoelectric effect in all three metals. Students, there is a graph given. It is stopping potential versus wave number, which is reciprocal of lambda for three different metals. And you have to extract the informations from the graph and select or have a look at the options and select the wrong option out of given 4. Now the idea is to Can you get any equation just by looking at the graph of stopping potential versus 1 over lambda? So now to get an equation, you have to express stopping potential in terms of lambda using Einstein's equation. Let me straight away take the Einstein's equation in this form. It is EV, which is maximum kinetic energy. I refer V to stopping potential. Let me write it as V naught itself. This is equal to incident energy minus work function. So that is incident energy in terms of wavelength is hc by lambda minus work function is phi. So this will be, let me take this e to that side. So this will be Vo is equal to hc by e lambda minus phi by e. When I compare this equation with the straight line equation, standard equation for straight line, look at this. This will be, this is of the form y is equal to mx plus c. That's why the graph is straight line, dear students. Have a look at this. In place of y, I have stopping potential, and in place of slope, can you tell me what is slope here? M is tan theta. Oh, let me write what is x. In place of x, I have taken 1 by lambda. So this is in place of x. So what should be the slope? Obviously, hc by e represents slope. Slope is hc by e. If the straight line makes an angle theta with the positive x-axis, then what is slope? Tan theta is slope. So what is my hc by e? It is tan theta for all the three metals. So hc by e is tan theta. I think that is one of the given options. Look at option B. Tan theta is equal to hc by e. It's a correct statement, but I'm supposed to find out the wrong one. So B is the correct statement. Now, how do you get any information about the work functions? Look at these x-intercepts. They are in lambdas. They are actually wave numbers, but the initial point corresponds to lambda naughts. They are the threshold wavelengths. So what I am trying to say is, for the first metal, 1 over lambda naught for the first metal is this one, 0.001. It is, I think, 1 by 1000, can be written as 10 power minus 3, or let me write it as 1 by 1000 itself, 1 by 1000. So this implies lambda naught for the first metal, threshold wavelength for the first metal is 1000. It is in nanometer, because 1 by lambda is per nanometer. So similarly for second and third, 1 over lambda naught for the second metal is 2 by 1000. Have a look at it. This is 0.002. It is 2 by 1000, which gives me lambda naught for the second is 1000 by 2, which is 500 nanometer. Similarly for the third metal, lambda naught 3 is 4 by 1000. This corresponds to the threshold wavelength of the third metal is 250, because it is 1000 by 4 is 250 nanometers. So what did I get from these three informations is that the threshold wavelength for the first plate is 1000 nanometer, for the second it is 500 nanometer, and the third one is 250 nanometer. Do I get any information about the work functions? Work function is phi is equal to hc by lambda naught. So work function is inversely proportional to the threshold wavelengths. The threshold wavelengths are in the ratio 4:2:1. So what should be the ratio of work function? Just the reverse of that. That is 1:2:4. Look at option A. Phi 1 is to phi 2 is to phi 3 is 1:2:4 is the right answer. I repeat, I got my information of phi by looking at lambda naughts, that is threshold wavelength. So option A is a correct statement, option B is correct option. Have a look at C and D. So which light can produce photoelectric effect in all the three metal plates? So just the idea of the threshold wavelengths will give you the correct answer, because to produce photoelectric effect, the incident wavelength should be less than threshold wavelengths. So you have to go for, to produce photoelectric effect in all three metal plates, the incident light should have a wavelength less than 250 nanometer. Obviously, visible cannot have wavelength less than 250 nanometer. Therefore, UV light is the only option out of the given options which can produce photoelectric effect in all the 3 plates. So what is wrong statement here? Visible light can produce photoelectric effect in all 3 plates is a wrong statement because UV light can produce effect in all the 3 plates. So the wrong statement is visible light, option D. ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇಂದಿನ ಸಂಚಿಕೆಯಲ್ಲಿ ನಾವು ಗ್ರಾವಿಟೇಷನ್, ಆಸಿಲೇಷನ್ಸ್, ವೇವ್ಸ್ ಹಾಗೂ ಡ್ಯುಯಲ್ ನೇಚರ್ ಆಫ್ ರೇಡಿಯೇಷನ್ ಆ್ಯಂಡ್ ಮ್ಯಾಟರ್ ಈ ಚಾಪ್ಟರ್ಗಳಲ್ಲಿ ಬರುವಂಥ ಕೆಲವು ವಿಚಾರಗಳನ್ನು ಹಾಗೂ ಪ್ರಶ್ನೋತ್ತರಗಳನ್ನು ನೋಡಿ ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀವಿ. ನಾವು ಅಭ್ಯಾಸ ಮಾಡಿದಂಥ ವಿಚಾರಗಳು ನಿಮಗೆ ಮುಂಬರುವ ಪರೀಕ್ಷೆಗಳಲ್ಲಿ ಸಹಾಯ ಆಗುತ್ತೆ ಅಂತ ನಾನಾದರೂ ಭಾವಿಸಿದ್ದೇನೆ. ನಾನು ಪ್ರವೀಣ್ KM ಹೋಗಿ ಬರ್ತಾ ಇದ್ದೀನಿ. ನಿಮಗೆಲ್ರಿಗೂ ಒಳ್ಳೆಯದಾಗಲಿ, ದೇವರು ಒಳ್ಳೇದು ಮಾಡಲಿ. ಆಲ್ ದಿ ಬೆಸ್ಟ್.